Alright, so today we're talking about 322. We're talking about sector area. The learning target says I can find sector areas. The formula is here. Go ahead and write this down. Sector area is abbreviated SA. That's not to be confused with surface area. If you just saw SA in a formula, you might confuse that with surface area, but we're not doing surface area. Analytic geometry only talks about sector area. The formula for sector area is area times the ratio, which more specifically is pi r squared times theta over 360. Notice that this formula is basically the same as the formula for arc length, right? Arc length is circumference times ratio, or 2 pi r, or pi times diameter times theta over 360. So these formulas are very, very similar, but we're not finding circumference, right? If we're talking about the area of a sector, look at that circle. So here's the area of a sector, right? And that is, not the area of the entire circle. It's just the area of that piece of the pie or piece of cake, or how about on a baseball field? Right? You've got this and this, right? And then you have the outfield, and it looks like that. That's a sector. Okay? What else might be represented by a sector? What's another real-life example of a sector? Piece of pie, right? A piece of cake. Everybody knows your desserts, right? Pizza, right? Okay, what else? Think about something in motion. What in motion might give you a sector?
A fan.
Well, a fan will probably go all the way around, and so that would be. But if you went from here to here, a clock, the hands on a clock. If you went from 12 o'clock to 3 o'clock, right? What would theta have to be? If you went from from 12 o'clock to 3 o'clock, if a hand moved from 12 o'clock to 3 o'clock, what would the theta have to be? It would have to be 90, right? What about from 12 o'clock to 6 o'clock? It would have to be 180, right? So those are examples, and if I said find this area, then that would be a sector area problem. The example I was hoping that you might think about is a sprinkler, right? If you have a sprinkler and you set it up to do a sector, and it sweeps across, right, and looks like this, and then it starts to go back, right, then that area covered by the sprinkler is a sector area, right? The sprinkler does this, and you can set it for this width, right, and that's theta right here, or you might widen it on out, right, and you might say, okay, I want it to be a little wider sector. Or you might narrow it up and say, I only want it to be this sector. Now theta is a smaller number, right? I like that one because it's in motion. Sectors don't always have to be static. It can be the sweep of something, or it could be a light, right? A beam of light coming out of a headlight would be a sector, okay? So I want you to think about that as we do some of these problems. All right, so the goal for the day is to be able to find sector area. So let's do an example of sector area. All right, if this is 120 degrees and it has a radius of 8, can you tell me the area shaded right here? Well, that's pretty easy, right? Sector area equals pi r squared, this is the formula, times the ratio of what? Theta over 360. Well, we know what r is. We simply put r right here. We substitute in r right there. R squared, 8 squared is 64. That'd be 64 pi. Okay? How about theta? What is theta in this case? 120, right? The area that's shaded has a central angle of 120 degrees. So that means that this amount right here is 120 degrees. Okay? So on our calculator, we would say 64 pi, or we could do 8 squared, it doesn't matter, times 120 over 360. Well, 120 over 360 reduces to 1/3, right? What is a third of 64? It's going to be a fraction, but give me the decimal equivalent. What is 64 pi divided by 3? Round like money.
57.
57, how much?
67.
67 point what?
02.
02, thank you. So if this is in meters, this would be in meters what? Squared. Why would it be in meters squared?
Area.
Because you're finding area. Okay, it's going to be in meters squared because you were finding the area, and area is always measured in units squared. Okay, questions? How is sector area similar to arc length? Well, the ratio part is exactly the same. Right? We're doing the exact same thing. Instead of circumference, though, because we're finding area, we have to do pi r squared. All right, let's do a little different one. Find the area of the shaded sectors. Parker, tell me how to do this problem.
We're finding both of them?
Yes?
Okay, well, you have to find the supplement of 80 to find the theta.
Very
That's
good.
100.
If this is 80, then this measurement from here to here has to be how much?
100.
Why?
Because that's the supplement.
Because these are a linear pair. Their linear pairs are supplementary. If that one's 80, that one's 100. So, tell me what to write down here.
So write pi 7 squared.
Very good. That would be the area of the entire circle. Then this is very important. What is my ratio? It's always some number over 360. What is my ratio?
200 over 360.
All right. He said 100 and you said 200. Could he get the right answer if he did 100? If he got his answer, what would he have to do then? Times it by 2. A much faster way, instead of plugging in 100 and then having to multiply by 2, is to make this ratio how much? 200. Right? If I put 200 degrees right there, right, then I know that that's 100 and this is 100. Why is this one down here 100?
Vertical angle.
Vertical angles. They got to be the same. Okay? So I can simply change my ratio to 200 over 360, type all that in, tell me what I get as a decimal.
85.
How much?
2 squared.
85 what?
Or 52 squared.
I can't hear you.
52.
8552? Is that right? Did everybody get that? Practice typing it in now. That's part of it. Pi times 7 squared times 200 over 360. See if you get 85. Is that what you got, Turner? Okay. Okay. Everybody got the same answer. Questions? All right, so that's sector area. What do you think we're going to do now? Instead of me asking you for the sector area, what do you think I might do now? Give you the sector area and ask you what? Find the radius or find the theta. What's going to be a little hard though when I ask you to find r? How are we going to undo this formula for r? We have to square root it, right? If this r is being squared, the way you undo that is with the square root. Okay, so let's try one of those. I'll do the first one for you, and we'll go from there. Sector area equals 28.26 meters squared. That's the area of the sector. The theta is 90 degrees, and we're asked to find the radius. Right? So we're going backwards, so to speak. If I was asked to draw this, you could say, 90 degrees right here. We're shading. We're trying to find r, and the sector area is 28.26 meters squared. Sometimes they give you a picture, sometimes they don't. You need to be able to do it without a picture. All right, so how do we do this? The sector area equals pi r squared times theta over 360. sector area is 2826 pi r squared times 90 over 360. Now some of you are going to realize that 90 over 360 is just 1/4. And that's the same as multiplying this side over here by 4. I'm going to recommend that you not do that. Right? Don't miss the problem because you simplified this fraction incorrectly. It's so easy to just multiply by the reciprocal 360 over 90 on both sides. There's no reason to miss a problem because you simplified incorrectly. Just leave it as 360 over 90. Alright, so I got rid of this by multiplying by the reciprocal. How am I going to get rid of the pi? I have to do that next. If it's being multiplied, how do I get undo multiplication? Very good. Division. Right? I divide by pi on both sides. Last step. Right? I got rid of the fraction. I got rid of the pi. How do I get rid of r squared? How do I undo r squared? I take the square root of what? The top, the bottom, what? All of it. I take the square root of this entire side and this, and I just get r. The result is just r. Now, eyes up here. Before we can type this in our calculator, you need to understand something. When you do this on the calculator and it opens up a parenthesis, and you type in and you close out a parenthesis and then say divide by pi, that pi is not underneath the radical anymore. So when you open up a parenthesis, you have to do 2 of them. And then you have to close it out at the end. So open with 2 parentheses and close with a parenthesis there. That's telling the calculator that all of it is underneath the radical. Alright, so here we go. Square root on your graphing calculator. The square root of open, parentheses. Do 2 of them. 360 divided by 90. Close parentheses, open parentheses. Right? You need to put a parenthesis right here around that. So you got 2 open, a close, an open, and a close. Then divided by pi, and then close it out. Hit equals, and what do you get? 5.99, approximately 6. If I said round to the nearest whole number, the answer is 6. Okay, anybody not get 6 on their calculator? You really got to remember to do those 2 parentheses, okay? Otherwise, you're not going to get the right answer. It won't put the pi underneath the radical. Here's a question. Could you do this and hit equals? And then divide by pi and hit equals? And then square root it? Sure you could. Nobody's saying you have to do it all in one step. I like doing it all in one step because it's easier for me to kind of do it that way. But you certainly don't have to. All right, questions? All right, you do this one. You try this one. Sector area 755.69 meters squared. The ratio is 240 degrees. Find the radius. Try this one now at your desk. All right, I see most of you are coming to a close. What's the answer? What'd you get? Scared? Round to the nearest whole number. 19. Very good. Anybody not get 19? Anybody want me to work it out? Raise your hand. Give me a little signal. Thumbs up and I'll work it out. Everybody get 19? Everybody? Anybody want me to work it out? All right, what am I going to do now? Good job on getting 19. Instead of me giving you these two and asking you for the radius, what am I going to do? I'm going to give you the radius and the sector area and ask you for the ratio. Okay, so try this one and then we'll do something different. Everybody gets this one right, we'll do something different. Sector area is 159.09 inches squared. The ratio is unknown and R is equal to 8. Plug the sector area in, we plug R in. 159.09 equals 64 pi. Where'd 64 come from?
8 squared.
8 squared, good. Times theta over 360. So this one's a little easier. We don't have to do the square root. But how do I undo all of this and this? Right? What do I do with the 360? How do I move it to the other side? Why multiply? What's the opposite of division? Multiplication. So if I multiply this side by 360, right, and I multiply by 360, these will cancel out. Okay, how do I get rid of 64 pi?
Divide.
Why divide? Because they're being multiplied. To undo that, I divide, right? I have students that want to multiply on both sides. Multiply by multiply doesn't get rid of it. You have to divide if you want to cancel it out. What is mandatory on the graphing calculator that you do with 64 pi? Parentheses. You must put this in parentheses. Okay, everybody type that in, practice. Type that in. And round to the nearest whole number, to the nearest degree, and tell me what you got. How much? 285 degrees. 285 degrees. Right? Do you think you can do that? Okay. Now I've got two challenge problems for you. See who's operating on a little higher level with sector area. Are you up for the challenge? Huh? Alright, here's the first one. I want you to find the sector area for the shaded regions. Find the sector area for the shaded regions. Let's leave our answers in terms of pi. Leave your answers in terms of pi. Oh, that did it for you? Huh? 2 miles? No, 2 miles. Leave your answers in terms of pi. right, anybody want to come up and work it out? Be on video for all time. Famous. I can make you famous. Swaby, you got the answer? Show it to me on your calculator or your paper. Anybody got the answer? You should be done. Where you at? I raised the bar. This is the type problem you might see on the SAT. This is the type problem. I know the answer. Do you know the answer? That's how it is. What'd you get, calculator boy?
17.
Nice. What'd you get? That's right. That's the right answer. Anybody else? Correct. I would write that in the front. It's not a big deal, but that's correct. All right, you want me to explain it? You want to come up and work it out? Huh, Turner? Here's a question, and this is about visualization. Okay, it really, this problem is not as hard as probably you made it. Okay, if I take this section right here and moved it there, and I take this section right here and moved it there, how much of the circle would be shaded? Half. What's the area of the entire circle? 5 squared times pi. Where did I get 5 from? If that's 3 and that's 2, then the radius of the entire circle is just 5. So the area of the entire circle is 25 pi. If I want the area of half of the circle, right, then what would it be? The ratio is 180 over 360, which is half. So the answer is 12.5 pi. You have to open up your brain a little bit and be able to see things and kind of move things around and piece things together. All right, so that was your first challenge. Are you ready for the second challenge? Huh? Okay, don't sound too excited. Sure. There's nothing difficult about this problem.
What are you asking?
I'm asking, great question. I'm asking for the area of the rainbow. Or whatever you want to call it. Cornucopia. Think about it. Dig deep. Don't just give up. Right? There's going to come a day when you're on a standardized test and you're going to see a problem like this and you're going to say, man, Coach Collins showed us one of those one time.
I thought you needed at least like 2 variables or whatever.
Am I giving, it's a semicircle. Am I giving you that variable that you seek?
If you have that, I think. I just have the radius.
It's 180.
Yes, please. Keep your answer in terms of pi. It makes it very easy. There's some wheels turning today, baby. Some people thinking in here. Some people are actively trying this problem, and that's a good thing. Don't give up on it.
No, I didn't get it. No, shut up.
Dr. Henderson. Still thinking? You're Come work it out? Huh? Make you famous? Didn't know you were ready on video for today. Mallard, what you got back there? Still thinking about it? All right, tell me what you got. Mouth it out. Don't yell it out. You want to come work it out? No? The video is scaring everybody away today. All right, here we go. What is the area of the big circle? I'll do a B right here for the big circle. Right? The entire circle, if I extended this on out, what would the area of it be? Well, the radius is 12. Right? What's 12 squared? 144 pi. That would be all of this area. Well, I know I don't want all of that area. I want half of that area. That would give me this semicircle right here, and I could find that out. So it's 180 over 360, which is the same thing as just dividing that by 2. Right? I would just say, hey, divide that by 2, and you get 72 pi. That's this entire area. Okay? So now we need to subtract out this amount right here, right? That's not shaded. So how can I figure out the area of this semicircle? Well, what's the radius? 6. So what is, here we go. Let me write it right here. The area of this little semicircle right here, what would it be? Well, the radius is 6. 6 squared times pi is just 36 pi. But that would be of the entire thing. So what do I need to do? I need to half that. Okay, so I half it and I get 18 pi. So this is the entire big semicircle, right? This is the area here of that. This is the area of the big semicircle is right here when I halved it. So this is the area of the little semicircle, right? All the way there. So what do I need to do with these two figures? Subtract. And 72 pi minus 18 pi is simply 54 pi. And there were a number of you that got there. So you looked at the problem initially and you were like, there's no way, right? But a lot of you kept working on it and you said, hey, I can get there. Okay? That's a great example of a problem that you might see down the road.